Hello and welcome back to Mathematics Academy. We are continuing part 3 for the chapter 3-dimensional geometry line. So take fourth shortcut. If a line OP makes angles theta 1, theta 2, theta 3 with the coordinate planes, then cos square theta 1 plus cos square theta 2 plus cos square theta 3 equal to what? The four options are 1, 2, 3 or minus 1. What is the value of this? Now look here. This is the line OB which is making an angle of theta 1 with xy plane. This is the xy plane. The angle made by OP with xy plane is theta 1. This angle is theta 1. Means the line is making angle theta 1 with xy plane. Therefore, its angle with z axis is 90 minus theta 1. Angle with z axis is 90 minus theta 1. Therefore, angle with z axis means gamma equal to 90 minus theta 1. Similarly, beta yz angle with x axis, that is alpha equals to 90 minus theta 2 and alpha and beta equals to 90 minus theta 3. So these are the angles made by the line with x axis, y axis and z axis. That is, these are alpha, beta and gamma. Therefore, cos square alpha plus cos square beta plus cos square gamma equal to 1. Therefore, cos square 90 minus theta 2 plus cos square 90 minus theta 3 plus cos square 90 minus theta 1 equal to 1. But cos 90 minus theta means sin theta. That is sin square theta 2 plus sin square theta 3 plus sin square theta 1 equal to 1. But sin square is 1 minus cos square theta 2 plus 1 minus cos square theta 3 plus 1 minus cos square theta 1 equal to 1. Therefore, 3 minus 1, that is 2, equal to cos square theta 1 plus cos square theta 2 plus cos square theta 3. So option 2 is correct. Now we are taking fifth shortcut. Two lines, x equal to ay plus b, comma, z equal to cy plus d. This is the one line. Second line, x equal to a dash y plus b dash, comma, z equal to c dash y plus d dash are perpendicular to each other. Then which of these four options is correct? Now first we write the equation in symmetric form. Take the first equation. X equal to ay plus b, z equal to cy plus d. That is, x minus b upon a equal to y, z minus d upon c equal to y. Both are y. Therefore, we can write x minus b upon a equal to y upon 1 equal to, this is also y, z minus d upon c. Similarly, second line can be written as x minus b dash upon a dash equal to y minus 0 upon 1 equal to z minus b dash upon c dash. Now, it is given that these lines are perpendicular to each other, therefore a1 A2 plus B1 B2 plus C1 C2 equal to 0. Therefore, A dash plus 1 into 1 plus C dash equal to 0. Means which option is correct? A dash plus C dash equal to -1. C option is correct. Now we are taking sixth shortcut. The coordinates of the foot of the perpendicular from the point P1 0 0 on the line x minus 1 upon 2 equal to y plus 1 upon minus 3 equal to z plus 10 upon 8 are. These are the four options. Clearly, the point which satisfies the equation of the line can be the foot of the perpendicular. But here, these 2 points, 3 minus 4 minus 3 4 2 and 7 minus 10 14, both satisfy the equation. For example, you put here minus 3 or you put 3 minus 1, that is 2 upon 2 is 1, minus 4 plus 1, minus 3 upon minus 3 is 1, and minus 2 plus 10, that is 8 upon 8, that is 1. Means this point satisfies the equation. We are putting minus 3, so minus 2 8 upon 2. So this, for example, look, the option C also satisfies the equation. Look here, 7 minus 1, 6 upon 2, that is 3, minus 10 plus 1, minus 9 upon minus 3 equal to 3, and 14 plus 10, 24 upon 8 means 3. Means these 2 points satisfy both the equation. So we have to decide which option is correct. But PM, suppose this point is M, so PM must be perpendicular to the given line. So what if you take this coordinate? For example, I take 3 minus 4 minus 2. Suppose I take first option. What are the direction ratios of PM? 3 minus 1, 2, minus 4, minus 0, minus 4, minus 2, 0, minus 2. And what are the direction ratios of the line? 2, minus 3 and 8. If this is perpendicular, then the relation A1 A2 plus B1 B2 plus C1 C2 must be equal to 0. So 2 2s are 4, 4 3s are 12, and minus 16, so it is 0. Means A option is correct. Now we are taking 7th shortcut. Find the shortest distance between the lines x minus 5 upon 2 equal to y minus 2 upon 7 equal to z plus 1 upon 5, and the line x minus 5 upon 4 equal to y minus 2 upon 7 equal to z plus 1 upon 1. Remember, these are the DRS, direction ratios of the lines. They are not same. Therefore, the lines are not parallel. They may be like this. There is one line and this is the second line. So then this must be the shortest distance between them. But here, this line passes through the point 5, 2, minus 1. And this line also passes through the same point, 5, 2, minus 1. It means both the lines are passing through the same point. It means the lines are intersecting. Therefore, the shortest distance is 0, obviously. Now we are taking shortcut 8. The line joining the points minus 2 and minus 8 and A, B, C is in the direction of the vector 6i plus 2j plus 3k. Then what are the values of A, B, C? So these are the 4 options. Now the line joins the point this and this. So what are the direction ratios of the line? A plus 2, B minus 1, C plus 8. These are the direction ratios of the line. But the line is in the direction of the vector 6i plus 2j plus 3k. Therefore, these direction ratios must be proportional to 6, 2 and 3. A plus 2 upon 6 equal to b minus 1 upon 2 equal to c plus 8 upon 3. Now these three ratios, we check which points, which numbers satisfy these three ratios. If you put here 2, this number 2 minus 3, 4. So 2 plus 2, 4 upon 6. And if you put here minus 3, so minus 4 upon 2. So this is not satisfied. So first option is rejected. Now put second option. 4 plus 2, 6 upon 6, 1. 3, 3 minus 1, 2 upon 2 is 1. And what is the minus 5? Minus 5 plus 3 upon 3 is 1. So these three ratios are satisfied by option B. So this is our correct answer. Now we are taking ninth shortcut. Find the direction cosines of the line 2x minus 1 upon 3 equal to 3y equal to 4z plus 3 upon 2. The equation must be of the form x minus some number upon a equal to y minus some number upon b, etc. But here is 2x. So divide numerator and denominator by 2. So what you get? X minus half upon 3 by 2. We divided this by 3 and this by 3. This by 2 and this by 2. Equal to, divide both by 3. So y minus 0 upon 1 upon 3. Equal to, divide by 4. Z plus 3 by 4 upon 2 by 4. That is 1 by 2. Now, these numbers are the direction ratios. So what are direction ratios? 3 by 2, 1 by 3, 1 by 2. 3 by 2, 1 by 3, 1 by 2. Now, if you multiply by LCM, what is LCM of this? 2, 3 and 2, 6. Multiply this by 6, this by 6 and this by 6. So this you get 9. Multiply by 6, so 2. Multiply by 6, so you get 3. So these are the direction ratios. Either this or this. So we take this. These are direction ratios. Now it is easy to find direction cosines. Under root a square plus b square plus c square. 94. So what are direction ratios? Direction cosines. 9 upon root 94, comma 2 upon root 94, comma 3 upon root 94. This is the answer. This completes part 3 of the chapter. If you like the video, please share, subscribe and comment. Thank you.